Hey everybody, this toolkit is for Unit 7, Lesson 2, Investigation 1 and 3, and this covers the Law of Sines, or as I sometimes call it, the Sine Rule. Now I've already written out the Law of Sines in two different ways here for us. Sine A over little a, sine B over little b, sine C over little c. All those things are equal to each other. Or we could write it as a reciprocal of that, little a over sine A equals little b over sine b equals little c over sine c. So what that means is that if we have enough information between an angle and its opposite side, we can come up with the value for one of the other sides or angles. And we know that all three of these things are equal to each other. So it doesn't matter if we have A and information for A and C, we can set those two things equal to each other. The thing to keep in mind though is that you cannot swap these things around. So you can't have like sine A over little a equals little b over sine B. Right? So you've got to keep it all in one string. So either all of the sine values on the top and the side values on the bottom, or all of the side values on the top and the sine values on the bottom. So just make sure you're keeping those proportions straight and in order. Okay, so when can we use these? We can use these with any any triangle. Any triangle at all. We generally use them with non-right triangles. Because when we have right triangles, we tend to use the basic the basic properties of sine, cosine, and tangent, being sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. So in right triangles, we tend to use those. In non-right triangles, we tend to use the law of sines. Okay, so let's look at a triangle. Let's throw in some labels here. So we've got A, B, and C. We've got little a, little b, little c. And when we're looking at this law of sines, it's telling us that we basically have to have some parts lined up with each other. We have to have sine A and little a. So we have to have that angle and that side, or we have to have this angle and this side, or we have to have angle C and side C, right? So we have to have some of those. So basically, to begin with, to even use the law of sines, we need to have at least one matching pair of angle and opposite side. Okay, so if we don't even have that, then we're in trouble. We can't really use the sine rule. So there's a few different possibilities to get that. The first being angle, side. So as you're working around the triangle, that might be angle A, angle C, and side A. And you can see there, as you're working around, we have the matching pair of A and little a. Angle A and little a. Or, you can go around to any of them. So angle, side, that's one possibility to use the sine rule. Another is angle, side, angle. So maybe we've got angle A, side B, and angle C. Now you're saying, wait a minute, you just told me we need to have one matching pair. Well, that's true, because we can actually find the other angle really easily. So if we had angle A, side B, angle C, we could do a quick 180 minus A and C, and we could find angle B, and now we can use angle, side, angle with law of sines as well. The third option is side, angle. But that one you have to be extra special careful with, because that is when you can get the ambiguous case. So side, angle again is if you have, let's say, angle or side C, side B, and angle C. Now we're given a matching pair there, but as we'll see in an example in a minute, that may not be as apparent. The answer may not be as apparent as we think it is. Okay, so let's look at a couple examples. So we'll start with a triangle here. We'll put 55 degrees in here, 41 over here. This side will be 11, this side will be x, y, and we'll call this theta. Okay, so what I want to do, or I want us to do, is find the missing parts of this triangle. So we're going to find the extra sides, or the missing sides, and the missing angle. Well, the missing angle theta is very easy. That's probably the easiest part of this whole thing. We can just take 180 minus our given angles, 55 and 41, and work that through to find the measurement of angle theta, which is 84 degrees. Okay, so that's our first part. Now we need to find our sides. So let's start with x. Now, I could use either of the properties or either of the law of sines as written above. I'm going to do the one on the right, and I'm going to match up side x with its opposite angle, sine of 41, and I'm going to put that in the denominator. The reason I'm doing that is because I have my unknown piece in the numerator, so that's going to make it a little bit easier for me to solve. Okay, so now I need to use a matching pair, which we have now that we know theta, so we can do 11 over sine 84. Now I said this is a little bit easier to solve. How do I get x by itself? Well, I just multiply both sides by sine of 41, and I'm left with x equaling 11 times sine 41 over sine of 84. Now I can drop all of that into my calculator, do a nice quick calculation, not have to worry about rounding issues. If I calculated out sine 41 or 84 previously, I might have some rounding issues. So if I just do this all in one shot, I get the whole answer, and that is approximately 7.26 units, whatever we're measuring in. So that's probably the best way to do it, because it's going to be as precise as we could possibly get with this type of thing. Okay, so now let's find side y. Again, I'm going to put my unknown in the numerator. So the opposite side of y is 55 degrees, so that's going to be y over 55, or sine 55, and that equals 11 over sine 84. Now I could have used the x and sine 41 again if I wanted, but I like to try and use with as much given information as I can when I'm calculating these things. In case I made a mistake in calculating x, now I'm kind of starting fresh here. Okay, so how do I get y by itself? I have to multiply both sides by sine 55, just like I did on the previous part, solving for x, and I get y equals 11 times sine 55 over sine 84. Throw all of that into my calculator, and I get y equals approximately 9.06. So there is my other side. I've got both missing sides. I've got my missing angle. I'm good to go. Alright, so let's look at another example. For triangle ABC, angle A is equal to 23 degrees, AC is equal to 16, and AB is equal to 8. And I want to find angle B. Alright, so I got to throw a triangle up here. Now, what we usually do is we just throw any triangle out there. I'm trying to be a little bit more precise with this type of triangle, and you'll see why in a minute. But when you're given information like this, where it's just information and not any kind of triangle drawn, it might be a good idea to just do, when you're doing your rough sketch of your triangle, try and make it as close and accurate as you can. I know you don't always have a protractor and a ruler available, but use your best estimate as you're trying to lay that out, and it might help visualize some of these things as we go through them. Okay, so here we've got angle A, B, and C, and we know that angle A is 23 degrees, AC is 16 units, and AB, actually that should be CB now that I think of it. So let me grab my pen here. So this here, let me fix this. This should be CB. I wrote down the wrong one when I first started the problem. Sorry about that. So CB should be 8. So that's going to be 8. And now we need to find our missing parts. Okay, so what are we going to do? Well, we've got a matching pair, so we can do our sine rule. So we're going to have sine of b, our unknown part, in the numerator, over 16 equals sine of 23 over 8. Alright, multiply both sides by 16, get sine b by itself, so we get 16 equals sine 23 over 8. And then we're going to just solve for this. So sine b is 0.7815. I just threw that whole thing into my calculator. I don't want to know what sine b is. I want to know what angle b is. So I'm going to do the inverse of sine of that same value, and I'll get b is approximately 51.4 degrees. Alright, so now how does this ambiguous thing work? What do we have to do if we have side-side angle? Well, there is a possibility that you could have the triangle look like this, and this was your measurement of 8. Now, if that were the case, let's call this B prime, so that way we know what we're talking about as I'm talking about this new triangle. So there is the possibility that we had a triangle ABC. It is possible that ABC was actually AB prime C too. We don't know which one I was talking about when I laid out this problem. So if we do that, we're looking for AB prime C now when we're looking for angle B, right? So that's the other possibility of what angle B could be. Since these two sides are equal, or potentially equal, we know that we've got an isosceles triangle. And if that's the case, then those two angles are equal. Now, because of that, we know that the blue angle is 51.4 degrees. So that means the red angle, AB prime C, is going to be 180 minus that, 51.4 degrees, or 128.6 degrees. So that is our potential second angle. So because we didn't know which triangle we were talking about, the black triangle ABC or the black and red triangle AB prime C, from the initial problem, since we didn't know which one it was, we have to look for both. Now, how do I know that it's one or the other? Or how do I know about that the second triangle works? Well, we have to check to see that it is okay to use that 128.6 degrees as a second possibility of angle B. So what I do is I take the new angle that I just found for AB prime C, that new angle 128.6, and I add it to the given angle of 23 degrees. And if I get a value, 151.6, then I know that that's safe. Well, how do I know that's safe? Because if triangle AB prime C plus the given angle of A is greater than 180 degrees, then we're not going to have an ambiguous angle, because we've now exceeded the number of degrees in the triangle. So we always check this first to make sure that we don't have an ambiguous case. Now, below I'm going to put a link to an application that you can play around with the idea of the law of sines and the ambiguous case. So take a look at that if this is a little confusing. Hopefully it's not. Hopefully we've got it all straightened out. That's it for the sine rule. I'll talk to you later. Peace out.